Hello everyone. Today we're going to learn how to calculate correlation coefficient, which is symbolized by the lowercase r. Before we go into any calculation, let's look at some background information. So the first thing we're going to do is to look at what is correlation coefficient. Correlation coefficient is a measure of the degree to which two quantitative variables are related. There are certain things I also want you to know. And remember, we're looking at two variables. So one variable, which is called variable x, which is the independent variable. The other variable is variable y, which is the dependent variable. What you also need to know is that if the values or value of the coefficient is positive, then the relationship or the correlation is direct. What this simply means is that if x increase, there will be an increase in y as well, and also vice versa. It is also important to note that if the values or value of the coefficient is negative, then it is an indirect relation or correlation. What this means is that if there is an increase in variable x, there will be a decrease in variable y, and vice versa. What you also need to note is the shape of the graphs that you may get. And so if you have a descending line and the incremental changes are equal or consistent or pretty much constant, then that will be perfect negative correlation. If you can identify the descending line as well, but they are slightly scattered, then we can say that that correlation is strong and negative. If you can still identify the descending line going down and the lines are more scattered, then, or pretty much very scattered, then we can say that it is a weak or about intermediate negative type of correlation. However, if you cannot identify a descending or ascending line, then we know that there is no correlation. So if the points are really scattered and random all over your graph, then definitely there will be no correlation. If you can see an ascending line, it therefore means that the correlation is positive and is pretty much weak if the lines are pretty much very scattered and you can only view that ascending line to a very small degree. However, if the coordinates or points are closer together but still scattered, then we can conclude that that relation or correlation is positive and also strong. However, if the incremental changes are pretty much equal and constant, then we can say that that is a positive and also a perfect correlation. Now, some ranges of numbers that you may look out for these graphs. For perfect is always 1, a value of 1. So the coefficient will be a value of 1. So if you are -1, perfect negative will be a -1. And if you're a strong negative, then you will have a value close to 1. So for example, -0.9, in fact. And if you're weak, then a good value, weak to intermediate, a matter of fact. So what you'll have here is a -0.5. So anything that is less than 0.5 going towards 0 will be a weak correlation. in no correlation, you'll have 0. And if you have a positive week, then a range of 0.5 is good. Slightly over 0.5 up to 0.7 is also good. Another example here of a number that could fit for strong will be 0.9. So once the numbers are really over 5 and very close to 1, then you can say those correlation are strong. Again, perfect is 1. So for positive perfect, it would be a positive 1. All right, and so these are examples of numbers that you can associate your graph or your coefficient with. Now, the formulas that you may use, there are more than one formulas that you can use, and so I'm going to display 2 formulas here, and they are of the same because it's just mathematically converted to the other. And so this is one formula. The other formula, which is coming from the first formula, just a simplified version. So let me explain what these mean within this formula. So R, which is the correlation coefficient, is equal to the sum of x, y, which is x times y, minus the sum of x multiplied by the sum of y divided by n. And I'm going to talk about what n is. A motherfucker will tell you what these are in a few. And all of that will be divided by the square root of the sum of x squared minus the sum of x all squared divided by n. Again, I will explain the difference between these two because I wanted to point out that here is you're looking at all the x valued squared, and then you find the sum of that. In this part right here, you will sum up all the x values, then you square that total. Divide by n, and n is the number of variables that you will have. I'm going to talk about that on the next part of this lesson. Here you have y, the sum of y squared minus the sum of y squared over n. Or it could be translated as this, because all you need to do is to multiply both sides of the equation by n, and it will convert to n multiplied by the sum of xy minus the sum of x multiplied by the sum of y divided by the square root of n times the sum of x squared minus the sum of x all squared multiplied by n, the sum of y squared minus the sum of y all squared. What is also important here, you need to determine the different part of the equation, and so you want to determine what n is, and n is a number of variable. So depending on how many variables you have or pair of variables, then that is your n value. The sum of x, so this symbol means the sum of x variable. So you're going to add up all the variable of x, or all the values of x, and also the sum of y, which means you're going to add up all the values of y. And then you have the sum of xy, which means you're going to multiply x and y and add all of those values. You also have the sum of y squared, which means you're going to square the y values and then add up all those values. You also have the sum of x squared, which means you're going to square x and add up all those values. Now, a question statement here for practice as an example is that it states that use the data chart to determine the correlation coefficient between age and height for the male siblings of the Browns family. So the data chart is given, and so the names of the male siblings of the Browns family include Barry, James, Walter, and Darius. The age, accordingly, Barry is 7, James is 10, Walter is 3, Darius is 18. their height in feet. Barry is 5 feet, James is 4 feet, Walter is 3 feet, Darius is 6 feet. Now, once you have your information, what you're going to do next is to find 3 other things based on your chart. So I'll always encourage you, once you have your X and Y values, and first you have to determine what your X and Y values are. And remember that X is the independent variable and Y is the dependent variable. And the way to identify them is that the independent variable will affect the dependent variable. So in other words, age will affect height. And so the other 3 things that I want you to find is XY and X squared and also Y squared. Once you have found all these 3 other factors, then you add up each column to find the sum of each column, and you'll make your life way easier in calculating the correlation coefficient. So now let's fill out this table. And so XY, you multiply 7 by 5, get 35, 10 by 4, you get 40, 3 by 3, get 9, 18 by 6, 108. Then you want to square the X values. You're going to square 7, square 10, square 3, and what you get is 7 square is 49, 10 square is 100, 3 square is 9, 18 square is 324. For the Y square, you want to square the Y values. So 5 square, 4 square, 3 square, 6 square. And what we'll get here is 5 square is 25, 4 square is 60, 3 square is 9, 6 square is 36. And then once you have done that, you want to add each column, which means you're going to find the sum of each column. So quickly, let's fill that out. And here you'll have 38 for the X column. For the Y column is 18. For the XY column is 192. For the X square values, you get 482. And for the Y square values, you get 86. Now, from this, you could plug that into your equation. And so let us look at it in this way. And so remember what N is, which is not shown in the chart, is the number of variables you have. And so we have 4 siblings here, or 4 set of each variables. So we have 4 X variables and also 4 Y variables. Or otherwise, you can say N represents the number of persons in the survey or in the interest of calculation. N can also mean the population size. And so now let's put this information inside of our equation. And so R is equal to 4 and 4 is N. So N is 4. Okay, so look at the equation. N is 4. 4 persons, the population size is 4, or there are 4 of each variables. Multiply by the sum of XY, and sum of XY right here is 192. So the total of this column is 192. Then you're going to minus from this the sum of X, which is 38, minus the sum of Y, and the sum of Y right here is 18. Then you're going to divide this by the square root of N, which is still 4, multiplied by the sum of X squared. So look at X squared column, which is 482. And this will be minus by the sum of X all squared. So the sum of X, which is 38. So you're going to say 38 squared. Then you're going to multiply that by N, the sum of Y squared. So you look at Y squared right here. All right, so look at Y squared. And that is 4 times 86, which is the sum of Y squared, minus the sum of Y all squared. And the sum of Y which is 18. So going to be 18 squared. Now let's now work out these portions of the equation. And so from the equation that we just written down, we're going to say R is equal to 768 because 4 times 192 is 768 minus 38 times 18, which is 684, divided by the square root, and write this part out. 4 times 482 minus the 38 squared, and 38 squared is 1444, multiplied by 4 times 86, which is 344, minus 18 squared, which is 324. Again, let us keep on working out the different portions of the equation. So the equation is there to remind you. And so R will be equal to 84 because 768 minus 684 is 84. And then let's work out this part in blue. And that will be 484 multiplied by 20. So once you minus 344 by 324, you get 20. And so let us work out here again. So we'll just remind you about the equation. And so working R is equal to 84 divided by the square root of 9,680, which is 484 multiplied by 20. Let's again go a little further by working out the square root of 9,680. And what we'll have here is 84 divided by 98.387. Now this is equal to 0.85. Now what this means, this is a positive value. So what this means is that if the value is positive, it means that it is a direct correlation. This value is close to 1, very close to 1. So this means that is a strong correlation. All right, which means that as age increases, the height of the male in the brown family will also increase. And strong correlation means that the incremental changes are pretty much close as well. All right, so this is where we end for today, and I want to tell you that I appreciate you watching these lessons, and I want to remind you that your goals and actions should always be positively correlated. Have a wonderful and blessed day.